Alright guys, so today in class we talked about writing equations from tables. So we talked about two different types. We talked about writing equations from the table that's given. We have talked about filling in tables based on an equation that is given. And then we talked about what in a table and a proportional equation look like. So that's where I'm going to start because a lot of your work today is going to be identifying whether it is proportional or not. So proportional equations are always written in the form y equals kx. Now, each of these variables has a very specific meaning, okay? The x is going to be your independent variable, okay? So this is the one that we change. It's the one that we pick, okay? Where y is your dependent variable, and that is the one that is changed based on your independent, okay? So it's going to have an answer based on whatever we change this x to be. Now, K is always going to be the unit rate, or we also know that as the constant of proportionality in a table or a graph. Okay, so here's a table that we worked with yesterday, and we're going to write an equation for this table. So we talked yesterday that this column here is always our X, okay, this column here is always our Y, and we can find the constant of proportionality by dividing Y by X, okay? So we have 5 divided by 2 gives us a 2.5. 750 divided by 3 gives us a 2.5. $10 divided by 4 gives us a 2.5. 1250 divided by 5 gives us 2.5, and so on throughout our table. So we know that our constant of proportionality, or our unit rate, is $2.50. So to write an equation for this table, we want it in the form y equals kx, okay? So we want to say you get your price, or your P, by taking our unit rate, which is $2.50, times however many pounds of candy that you buy, okay? So I'm going to put that with a C. So we have the price equals $2.50, which was our unit rate, times, remember that when there's no operation here, when there's just a variable, that means times however many pounds of candy that you buy. Okay, so our equation would be P equals 250 times C. Okay, and that is a proportional equation because it's of the form y equals kx, and because we wrote it from a proportional table. Okay, all right, so checking tables for proportionality. So if we have a table, we know that we can check to see if it's proportional or not by checking the unit rates. So again, our first column is our x, and our second column is our y, and we can find the constant of proportionality, or we can find the unit rate by dividing y by x. So 4 divided by 3 gives us a 1.33. 6 divided by 8 gives us a 1.333 repeating. 9 divided by 12, 1.333 repeating. 16 divided by 12, 1.333 repeating. 20 divided by 15, 1.1333 repeating. So yes, this is a proportional table because every row has the same unit rate. That means we've got the same constant of proportionality throughout. The equation then would be y equals 1.333 times x, because we have our y's equal our unit rate times whatever x value. If we put that in our calculator, 3 times 1 1/3, we would get 4. 6 times 1 1/3, we would get 8. Okay, all right. So let's take a look at our second table. First column is our x's, second column is our y's. We're checking to see if it's proportional first. So we're going to do our constant of proportionality, y divided by x. 2 divided by 5 would give us a 0.4. 4 divided by 7 would give us a 0.57. 6 divided by 9 would give us a 0.66. 9 divided by 12 would give us a 0.75. And then 15 divided by 8 would give us a 0.83. So no, we know that this table is not proportional because the constant of proportionality is not the same. However, we can still write a rule or an equation for this table by looking at what we're doing to the independent, or the x variable, to get the y. Okay, so if we take a look here, to get from 5 to 2, we would subtract 3. To get from 7 to 4, we would subtract 3. To get from 9 to 6, we could subtract 3. Same thing for 12 to 9 and 18 to 5. So we could take, to get y, we could take x and subtract 3 every time. So that is an equation for this table. Y equals x minus 3. Now, we know it's not a proportional table, and if you look at the equation, it is not in the form y equals kx. So we also know that it's not proportional because the equation for the table is not of the form y equals kx. Okay, all right, so on this type of table, they've given us the x values and they've given us the equation, and we need to fill in the y values and decide if it's proportional or not. So it says here y, or our second column, equals 5 times x. So we would take our x of -2, multiply it by 5 and get -10. X of -1, multiply it by 5 and get -5. Okay, so we're going to take 0 times 5 and get 0. 1 times 5, 5. 2 times 5 is 10. 3 times 5 is 15. 4 times 5 gives us 20, and then 5 times 5 gives us 25. Now we have to decide if this is proportional or not. And first off, there's a couple of different ways that we can tell if it's proportional or not. This does represent a proportional table because y equals 5x, that is of the form y equals kx. So we know right now that the equation is proportional because it's of that form. We could find the constant of proportionality for every row, and it would be the constant of proportionality, or the unit rate would be 5. I can also tell that if I were going to graph this, it would be through the origin, okay? So there's lots of different explanations. Yes, this table is proportional. The constant of proportionality is 5. The equation is of the form y equals kx, and I can tell that this line would go through the origin. Okay, so let's look at another table. If we look at this table, we have our x values, and we have the rule, or the equation, y equals x plus 4. So we're going to take all of our x values, and we're going to add 4. So -2 plus 4 would give us +2. 0 plus 4 would give us 4. 2 plus 4 would give us 6. 4 plus 4 would give us 8. 6 plus 4 would give us 10. 8 plus 4 would give us 12. 10 plus 4, 14. And then our last one would be a 16. Now, looking at this table, we need to determine if it is proportional or not. And again, there's lots of ways that we can do that. We can tell, number one, this equation is not proportional. The equation is not of the form y equals kx. So we've got x plus 4 here, not the same thing. Our constant of proportionality would be different for every row of the table. For this row, it would be a -1. Okay, for this row, it would be 0. For this row, it would be +3. This row would be +2. So it would be different for every row of the table. Also, I can tell that by looking at our table, our x value would be 0 and our y value would be 4, so it does not go through the origin. So again, there's lots of reasons why this does not represent a proportional table. So no, this table is not proportional. The constant of proportionality is not equal, and the equation is not of the form y equals kx, and we can tell that these ordered pairs would not go through the origin.